Target down.
First problem is for model of cost, revenue, and profit. The O'Neill Shoe Manufacturing Company will produce a special style shoe if the order size is large enough to provide a reasonable profit. For each special style order, the company incurs a fixed cost of $1,000 for production setup. The variable cost is $30 per pair, and each pair sells for $40. So first, we need to write the given. The fixed cost is $1,000. The variable cost is $30 per pair. And the selling price is $40. For question A, let X indicate the number of pairs of shoes produced. Develop a mathematical model for the total cost of producing X pairs of shoes. We're looking for the total cost. The formula is the fixed cost plus the variable cost multiplied to X, which is the number of pairs of shoes produced. So it would be the variable cost, which is 30,000, and the fixed cost, which is $1,000. For B, let P indicate the total profit. Develop a mathematical model for the total profit realized from an order of X pairs of shoes. We're looking for the profit, and the formula is the selling price and the X pairs of shoes minus the total cost. So it would be P is equal to $40X, the selling price, minus the total cost. It would be equal to 10X minus 1,000. So for letter C, what is the break-even point? The break-even point, which yields zero cost, zero profit, where break-even point where total cost is equal to revenue. So P would be equal to 0, and it would be 10X minus 1,000 is equal to 0. Would make it equal to get X, we need to divide both sides by 10. And we would get 100. So the break-even point occurs if only 100 pairs of shoes were sold. Introduction to probability. The problem is, small cars get better gas mileage, but they are not safe as bigger cars. Small cars accounted for 18% of the vehicles on the road, but accidents involving small cars led to 11,898 fatalities during a recent year. Assume the probability a small car is involved in an accident is 0.18. The probability of an accident involving a small car leading to a fatality is 0.128, and the probability of an accident not involving a small car leading to a fatality is 0.05. Suppose you learn of an accident involving fatality. What is the probability a small car was involved? The problem can be solved by constructing a Bayes theorem, which has prior probabilities, conditional probabilities or new information, joint probability, and posterior probability. The prior probability for a small car is 0.18. We should get the probability for the big car, so we would subtract 1 to 0.18, which yields to a difference of 0.82. The conditional probability for small car is 0.128 and for big car is 0.05. The joint probability can be computed by multiplying the prior probability and new information. The joint probability for small car is 0.18 times 0.128, and the answer is 0.023. While for big car, it is 0.82 times 0.05, and the answer is 0.041. We should get the sum of the two joint probabilities, 0.023 plus 0.041 is equal to 0.064. The posterior can be computed by dividing the joint probability of the small car to the total joint probability. The answer would be 0.359. Same with the big car, we would divide 0.041 to 0.064. The answer would be 0.641. The sum would be 1. The question is, what is the probability a small car was involved? We could look for the answer by looking at the value of the posterior probability of a small car, which is 0.359. 0.359 is the probability small car is involved in the fatality in the accident, while 0.641 is the fatality in the accident.
So now we are going to move to the probability distribution. The question is, a Harris Interactive Survey for intercontinental hotels and resorts asked respondents, when traveling internationally, do you generally venture out on your own to experience culture or stick with your tour group and itineraries? The survey found that 23% of the respondents stick with their group, or according to USA Today, January 21, 2004. So for this problem, we are going to use the formula of Px is equal to NCx times P to the power of x times Q to the power of n minus x. So this is where n is the total number of travelers in the sample, x is the number of travelers sticking with the group, P is the probability that a traveler stick with his group, and Q is the probability that a traveler will not stick with his group. So from the question, we are going to take the P is the probability that a traveler stick with his group. From the question, there are 23% that is respondents stick with their groups. So the P is P.23, and then we are going to look for Q is equal to 1 minus P. So Q is always 1 minus P. So 1 minus 0.23 is equal to 0.77. So now we are going to move to question A. In a sample of 6 international travelers, what is the probability that 2 will stick with their group? For A, so the n is 6 and then the x will be 2. So in this problem, we will just substitute the values of N, X, P, and Q into the equation. So, probability that 2 will stick with his group is equal to 62 times 0.23 to the power of 2 times 0.77 to the power of 4. So it will be equal to 0.278933938 and or 0.28. So now we are going to move to the question B. In a sample of 6 international travelers, what is the probability that at least 2 will stick with their tour group? So N will be the 6, and then X will be 2 or 3 or 4 or 5, because it said at least 2 will stick with the tour group. So in here we will calculate how to look for the P probability that X is bigger than 2. So is equal to 1 minus P, X is bigger than 2, equal to 1 to the parenthesis of P, X equal to 0 plus P is equal to 1. And then is equal to 1 minus 6CO times 0.23 to the power of 0 times 0.77 to the power of 6 plus 6C1 times 0.23 and then 0.77 to the power of 5 is equal to 1 minus 0.581958593 or equal to 0.42. Now we are going to proceed with letter C. In a sample of 10 international travelers, what is the probability that no one will stick with their tour group? So N is equal to 10 and then X is equal to 0 because it said what is the probability that none will stick with the tour group. So for these problems, we just need to substitute the formula with the numbers. So N is equal to 10, X is equal to 0. So the probability that 0 that will stick the tour group or no one will stick the tour group is equal to 10CO times 0.23 to the power of 0 and then times 0.77 to the power of 10 is equal to 0.0732668804, or you can round them off, it becomes 0.07. So the answer is 0.07.
The problem in the decision analysis is the following payoff table shows profit for a decision analysis problem with 2 decision alternatives and 3 states of nature. This is the table. For letter A, we should construct a decision tree for this problem. For letter B, if the decision maker knows nothing about the probabilities of the 3 states of nature, what is the recommended decision using the optimistic, conservative, and minimax regret approaches? For letter B, we should find the optimistic approach. You should find the highest value of S, which is 250. For the conservative approach, you don't want the worst scenario to happen, so you try to avoid it. This is like counter approach to optimistic. You should find the lowest and choose the highest among them. For D1, 25 is the lowest. And for D2, 75 is the lowest. Conservative approach tells you to choose D2 since 75 is higher than 25. For the minimax regret approach, you have to avoid the worst situation where you would regret most badly. You have to find what you would regret when you choose the decision D1 or D2, then the highest minus the lowest. For example, 250 minus 100 is equals to 150. So if you choose D2 and S2 happens, your regret about your decision is 150. For S2, 100 minus 100 is equals to 0. For S3, 75 minus 25 is equals to 50. You should write the value for D1 and D2 and choose the lowest among the two, which is the minimax regret. Be careful that you should subtract vertically, not horizontally.
So the next topic is utility and game theory. So a firm has three investment alternatives. Payoffs are in thousands of dollars. So this is the table. Then the first question is, using the expected value approach, which decision is preferred? For the first question, we're going to use the expected value approach to get the expected value. For investment A, we're going to multiply 100 to its probabilities. So 100 times 0.40 plus 25 times 0.30, then plus 0 times 0.30. So the answer is 47.5. All same way to solve D2 and D3. For investment B, the answer is 52.5. Then for investment C, the answer is 50. So D2, which is the investment B, is the decision preferred because it is the highest. On letter B, for the lottery having a payoff of $100,000, which probability P, and 0 with probability 1 minus P. Two decision makers express the following difference probabilities. Find the most preferred decision for each decision maker using the expected utility approach. For B, to do the expected utility approach, we have to multiply 10 to each indifference probabilities in the table. So 10 is for the highest value and 0 is for the lowest value. So for decision maker A, 10 is for 100, 8 is for 75, 6 is for 50, 3 is for 25, then the lowest 0 is for 0. So it's just like the procedure in question A. We're going to multiply all the values to its probability. So for A, 10 times 0.40 plus 3 times 0.30 plus 0 times 0.30. So the answer is 4.9. And same for investment B, the answer is 5.9. And last, for investment C is 6. The highest EUV is the best decision to make. For decision maker A, the answer is 6. For decision maker B, the highest is 10 for 100, 8 for 75, 6.50, 1.5 for 25, and 0 for 0. It's just like the procedure in question A. We're going to multiply all the values to its probability. So 10 times 0.40 plus 1.5 times 0.30 plus 0 times 0.30. For investment A, the answer is 4.45. For B, the answer is 3.75. And for C, the answer is 3. So the highest EUV is the best decision to make. So for decision maker B, the answer is 4.45. For the question C, why don't decision makers A and B select the same decision alternatives? So they don't select the same because the EUVs are different. It means their decisions that would make them the highest profits are different from each other.
So now we are going to talk about forecasting. Moving averages often used to identify movement in stock prices. Daily closing prices in dollars per share for Sandisk for August 16, 2002 through September 3, 2002. Follow. So this is the datas of the August 16, 2002 until September 3, 2002. So the question number 1 is, use a 5-day moving average to smooth the time series. Forecast the closing price for September 4, 2002. So first thing that we are going to do is that from the question it said that we have to use 5-day moving average. So from this the data, we have to choose 5 datas. So from August 16, August 19, 20, 21, 22. So all of these are 5 datas. And then we have to add everything up and then divide it by 5. So we are going to add the first data until the 5th data. So the first data is 14.45 plus 15.75 plus 16.45 plus 17.49 plus 17.32 and then divide it by 5. So the answer, we will replace it at the 6th line. So this is the 6th line. The answer is 16.22 at 29. So we are going to replace the answer at the line of 6 because it is 5-day moving average. We are going to place the answer at line of 6. So the answer is 16.292 and then we are going to round it off, become 16.29. And then the second one is start from number 2. So 15.75 plus 16.45 plus 17.49 plus 17.32 plus 15.96 and then divided it by 5. And then the answer will place at the line of 7. So is 16.594. So we are going to round it off, become 16.59. And then you are going to do it so on until it finishes at September 4th. Until the data is, if you are done calculating everything, sum it up and then divide it by 5. So the second thing that we are going to do is look for the error. So if you are going to look for the error, you should get the data minus the 5-day moving average. So the line of 6, so we are going to get the data of number 6, that is 15.96 minus the one in 5-day moving average, that is 16.29. So the error is negative 0.33. The second one that we are going to do is get the 7th data. And then the 7th data is 16.45 minus 16.59. So we're going to get the data of negative 0.14 and then so on until it finished again. The next thing we are going to do is going to look for the MSE or mean squared error. So we are going to square everything and then add everything divided by 1, 2, 3, 4, 5, 6, 7, 8. So we are going to divide it by 8. So it is 0.33 squared plus 0.14 plus 1.13 plus 1.47 plus 0.34 squared plus 0.31 squared plus 0.73 squared plus 0.62 squared. And then we got 4.6953. And then we are going to divide it by 1, 2, 3, 4, 5, 6, 7, 8. Divided it by 8. The MSE is 0.59. 0.59. So we are going to move to number 2. Number 2 question is, use a 4-day weighted moving average to smooth the time series. Use a weight of 0.4 for the most recent period, 0.3 for the next period back, 0.2 for the third period back, and 0.1 for the fourth period back. Forecast the closing price for September 4, 2012. So, we're going to make the 4-day weighted moving average. How to do the 4-day weighted moving average? It is, so you have to get the data from the fourth. So we are going to get 4 data for data number 1, 2, 3, and 4. So, how to calculate this? It is like from bottom to top. So, data number 4 is 17.49. We are going to times it with the 0.4. And then data number 3 is 16.45. We are going to times it with 0.3. And then next one is 0.2. We are going to times it with 15.75. And then the next one is 0.1. We are going to times it with 14.41. So, it is like this. 0.4 times the 17.49 plus 0.3 times 16.45 plus 0.2 times 15.75 plus 0.1 times 14.45. So we get 16.53. So we are placing the answer at the line of 5 because we are looking for 4-day. Always put the answer at line of 5. For example, if you are going to look for 3-day weighted moving average, so you're going to place the answer at the 4th line. But this is we are looking for the 4-day, so we are placing it at the line of 5. So the next thing to do is for the line after this, we are going to look for August 23. So it is from the line 5th. We are done with the 14.45. So we are going to start from 2, 3, 4, and 5. We are going to look for the 4 data. So start from 2 until 5. But you can also make it from bottom to top, and then you can make it top to bottom. Now we are going to look for August 23. We are done with the August 16. Now we are going to start from August 19. You are going to count for 4 data. So, data 2, data 3, 4, and 5. So, the 17.32, we are going to times it with 0.4. And then, 17.49, we are going to times it with 0.3. And then, 16.45, we are going to times it with 0.2. And then, 15.75, we are going to times it with 0.1. So, 17.32, 0.4, 17.32 plus 0.3 times 17.49 plus 0.2 times 16.45 and then plus 0.1 times 15.75. So we are getting 17.04. And then we are going to get August 26. We are done with the August 19 and then the price is 15.75. So we are done with this. So we are going to get the 4 datas again. So start from 3, 4, 5, and 6. And then again, so 15.96 times 0.4, 17.32 times 0.3, and then 17.49 times 0.2, and then 16.45 times 0.1. So, 15.96 times 0.4 and then plus 17.32 times 0.3 plus 17.49 times 0.2 plus 16.45 times 0.1. So we are getting 16.72. This is 16.72. And then the next thing we are going to do, like earlier, we're going to look for the error. So we are going to get the data. So the data 1 to 12 minus the data from 4-day weighted moving average that we got earlier. So August 22 or number 5. So we are getting data number 5. Data number 5 is 17.32. We are going to minus 17.32 with the 16.53. So, 17.32 minus 16.53. We are getting 0.79 and we are going to do until it is done. After we are getting all of the error, we are going to square everything and then add everything up and then divide it by 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are going to divide it by 9. So 0.79 square plus 1.08 square plus 0.27 square plus 0.98 square plus 1.01 squared plus 0.82 squared plus 0.35 square plus 0.77 square plus 0.65 squared plus. So we're getting 5.65 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9. Divided it by 9. The MSE is 0.63. We are done with number 1 and 2. Now we are going to move to number 3. Number 3 is use exponential smoothing with a smoothing constant of alpha is equal to 0.7 to smooth the time series. Forecast the closing price for September 4, 2002. So, we are going to use 1 minus alpha. 1 minus 0.7 is equal to 0.3. So, this is how we are going to use the exponential smoothing. We are going to get the first data. The first data is 14.45. We are going to put this 14.45 at the second data. So, we are putting it at the second data, 14.45. And then, we are going to get the second data, 15.75. We are going to multiply it to 0.7. And then, we are going to get the 14.45, multiply it by 0.3. So, we are going to get 15.75 multiply it by 0.7 plus 0.3 times 14.45. So we are getting 15.36. So we are going to place. So we are done with August 20. We got it 15.36. Now we are going to August 21. It is number 3. So we are done with number 1 and 2. So now we are going to get the data number 3. From number 3, we are going to get 4 data. Number 3, number 4, number 5, and number 6. So we are going to get it from the bottom. From number 6, 15.96. 15.96 times 0.4 plus 17.32 times 0.3 plus 17.49 times 0.2 and then plus 16.45 times 0.1. So we get 16.72. So we got 16.72. So here is the 16.72. After that, as usual, we are going to look for the error. So we are going to get the second data because it is we start at the second line. So we are going to get the second data. Second data is 15.75. We are going to minus 15.75 minus 14.45. So 15.75 minus 14.45. We got 1.3. Here is the 1.3 and then do it so on after it is done. And then after that, we are going to square everything and then add everything up and then divide it by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 1.3 squared plus 1.09 squared plus 1.37 squared plus 0.24 squared plus 1.29 squared plus 0.1 squared plus 0.82 squared plus 0.76 squared plus 1.1 squared plus 0.12 squared plus, it is not enough, so we're going to add this and then plus 0.95 squared plus and then divided it by 11. So the MSE is 0.89, and then so on. So we are going to round it off. It becomes 0.90. So here is the 0.90. So now we're going to number 4. Which of the three methods do you prefer and why? So we already got the 3 MSE or mean squared error from 5 days moving average, from weighted moving average, and exponential smoothing. So from MSE 5 days moving average, we got 0.61. MSE weighted moving average, we got 0.65. And then MSE exponential smoothing is 0.9. So we are going to prefer the lowest error that we have. So the lowest is 0.61 of all. So we are going to prefer 0.69 from the MSE 5 days moving average.